In this video, we're going to introduce one of the newest modules in Present Studio, our 3D mesh generation system. One of its most interesting features is that it doesn't rely on a single AI model. Instead, it uses a pipeline built around two specialized models working together. The first model is Gemma 4. Its job isn't to generate images, but to assist the user in creating the best possible prompt. It analyzes the request, reorganizes it, makes it more precise, and finally converts it into a structured JSON format that is sent to the image generation model. This may sound like a technical detail, but it's actually one of the key factors behind the quality of the final result. A well-structured prompt allows the image model to understand much more clearly what it is supposed to create and, just as importantly, the creative boundaries within which it should operate. The result is a more coherent and significantly higher quality image. In this demonstration, the image generator is Qwen Image 2512. To really showcase the capabilities of the system, we intentionally provided it with a fairly complex prompt designed to produce highly detailed images suitable for 3D mesh generation. Once the image has been created, we can move on to the next stage, generating the actual 3D mesh. Present Studio Mesh supports two different generation engines. There's a light version, designed for computers with more modest hardware, and a pro version intended for more powerful systems capable of producing significantly more detailed meshes. Which version is available simply depends on the hardware installed on the machine running Present Studio. For today's demonstration, we'll be using the pro version. The interface also includes two separate galleries. The first gallery stores every image generated by the image creation module. The second contains all previously generated 3D meshes, allowing users to reopen existing projects at any time without repeating the entire generation process. We're still refining parts of the interface and improving the overall user experience, but even in its current state, it already provides a very clear picture of how the complete workflow operates. Once the mesh has been generated, it can be exported directly into a format compatible with modern slicing software. In our case, we're using Orca Slicer. This is where the real quality of the generated models becomes obvious. We'll take a closer look at several examples, including the Dwarf King, the Ancient Greek helmet, the Crouching Dragon, the Mimic Chest, and the Gargoyle, all created from AI-generated images before being converted into printable 3D meshes. Viewing these models inside Orca Slicer clearly demonstrates the level of detail, the cleanliness of the geometry, and the overall quality achieved by Present Studio Mesh. These characteristics are particularly important when the final goal is high-quality 3D printing. The next logical step would be the actual printing process, but we'll be covering that in a separate video. For now, our goal is to demonstrate the complete production pipeline from prompt creation to image generation, and finally to fully automated 3D mesh generation. The Hunyuan viewer still requires some additional optimization, and there are a few interface improvements already on our roadmap. These refinements will be introduced in upcoming releases. Our next major milestone will be the addition of support for fully colored 3D model generation, bringing an entirely new level of realism to the workflow. This is only the first version of the mesh module, but we believe it already demonstrates the direction we're taking with Present Studio, making professional quality 3D asset creation faster, simpler, and more accessible, while maintaining the level of detail required for creative projects and high-quality 3D printing. Thank you for watching.